Let's work on better understanding the coordinate plane and integer and rational number operations together. For number one, let's go ahead and practice finding the sum of each of these integers. So by integers, we're staying away from fractions and decimals right now, and the word sum here means that we are adding, okay? All right, for 1a, we have negative 9 plus 5, so since they have opposite signs, we're going to do 9 minus 5, that's going to be 4. And then since negative 9 has a greater absolute value, that one is going to be a negative 4, okay? For 1b, we have 14 plus negative 8. Again, these have opposite signs, so we can do 14 minus 8, subtract their absolute values. That's going to equal 6. This time it's positive because 14 had a greater absolute value, and it's positive. For 1c, we have negative 11 plus 19. Again, they have opposite signs, so we can take 19 minus 11. That's going to be 8. And we're going to keep that as a positive value because 19 has a greater absolute value than negative 11. For 1d, we have a negative 7 plus negative 12, so they're both negative. So we're going to add their absolute values. 7 plus 12 is 19. And since a negative plus a negative is always going to be negative or never positive, we're going to write negative 19 here. Add their absolute values, keep the sign. For 1e, we have 16 plus negative 11. They have one positive, one negative in this problem, so we're going to subtract 16 minus 11. That's going to be 5. And since 16 is further from 0, it's going to be a positive 5 here, not negative 5. For 1f, we have 8 plus negative 13. Again, they have opposite signs, so 13 minus 8, take away their absolute values, that's going to be 5. But in this case, it's going to be a negative 5 since negative 13 has a greater absolute value than positive 8. Let's check out number 2. For number 2, let's switch gears a little bit. Instead of adding, we're going to be finding the difference of integers, so staying away from fractions and decimals still, but we are going to be subtracting instead of adding here, okay? Also, in the directions here, we are told to rewrite each of these as a sum first. So that means we're going to change all these subtraction problems into addition problems. So for 2a, we can keep, change, and flip, or we can add the opposite, however you think about that. If we add the opposite here, this is going to stay as a negative 5, and we're going to add a negative 9 instead if we flip that. So we're going to add the opposite, give that negative 9 a hug. Negative 5 plus negative 9, they're both negative, so add their absolute values, and we get a negative 14. For b here, we have negative 4. We're going to keep and then change, and then we're going to flip. So the equivalence here as a sum is going to be negative 4 plus a positive 10. And since we have one negative, one positive, it's going to be 10 minus 4. That's going to be 6, and we'll keep it positive. For number 2c, we have 5 take away a negative 18. So when we have this, we're going to take this and rewrite it as 5 plus a positive 18. And 5 plus 18 is equal to 23. Moving on to 2d, we have a negative 14, and then we're going to take away 19. So rewriting this as a sum, we'll have negative 14, and then we'll add on a negative 19. Okay, so adding the opposite here, negative 14 plus negative 19 is going to be a negative 33. For 2e, we have 13 take away 19, so we're going to rewrite this as a sum. So instead of saying 13 minus 19, we can also say 13 plus the opposite of 19. So that's going to be negative 19. And when we do that, they have opposite signs. So 19 minus 13 is going to be 6, and it's going to be a negative 6 here. Okay. One more here, we have negative 16 take away negative 9. Rewriting this one as a sum, we're going to have negative 16 plus a positive 9. And so 16 minus 9 here is going to be 7. They have opposite signs, so we're subtracting, and the answer is going to be negative. All right, here's number 3. For number 3, let's go ahead and find the product or the quotient of each of the following integers. So again, still staying away from fractions and decimals right now. And again, product just means we are finding the answer to a multiplication problem, and quotient means we're finding the answer to a division problem, okay? For number 3a, let's just go ahead and multiply 9 times 4. 9 times 4 is 36, but we have the opposite of 4, so we're going to have the opposite of 36. For 3b, we have negative 2 times negative 7. Just multiply 2 times 7, that's going to be 14. Because we have two opposites, the opposite of 14 is just 14, so that is done. For 3c, we have negative 15 times 6, so 15 times 6 is 90, but since we have the opposite of 15, it's going to be the opposite of 90. For 3d, we have negative 96 divided by 6. 96 divided by 6 is equal to 16, but since we have the opposite of 96, we should have the opposite of 16. For 3e, we have 56 divided by negative 8. So 56 divided by 8 is equal to 7, but we're dividing by the opposite of 8, so we should have the opposite of 7. Finally, for 3f, negative 72 divided by negative 4. 72 divided by 4 should be 18, and because it's a negative divided by a negative, or the opposite of 18, that's just going to stay as 18. Here's number 4. For number 4, let's go ahead and find the sum or the difference for each of these rational numbers. So when I say rational, we're introducing our fractions and our decimals. Sum and difference, we're adding and subtracting, so it could be either or. And then we're going to make sure that we simplify or simplify whenever possible. So that's mainly directed towards the fractions. All right, so for number 4a, we have negative 5.2 plus 2.9. One's negative, one's positive, so we need to go ahead and subtract their absolute values. So let's take this 5.2 and take away this 2.9. Okay, to go ahead and subtract here, we're going to borrow from this 5, make it a 4, and give that 10 over here to the 2, so it becomes 12. 12 minus 9 is 3, and then 4 minus 2 is 2. So we're getting 2.3 here. Okay, so we're going to get 2.3, but keep in mind which number had a greater absolute value. It was negative 5.2, so this should be negative 2.3. Okay, looking at 4b, we have 4.56 plus negative 8.23. Again, we have opposite symbols here, so one positive, one negative. The answer should be negative for this one, just because the negative 8.23 has a greater absolute value. So let's go ahead and subtract these. Let's take this 8.23 and then subtract the 4.56. Let's go ahead and set that up here. Okay, so we're gonna have to borrow a couple times here. So let's make this a 7. We can make this a 12, but we'll have to borrow again. So let's make this 11 and then give this to the 3, so that's 13. 13 minus 6 is going to be 7. 11 minus 5 is going to be 6. Bring the decimal straight down. 7 minus 4 is 3. Okay, so we are going to get a negative 3.67. All right, for 4c, it looks like we have some fractions. Lucky for us, we have some common denominators, which is really nice. When we're showing our work here, let's go ahead and put the negative to the numerator. So it's negative 5 plus 21 and put that over 12. Again, we like these common denominators, so that's nice. In the top here, negative 5 plus 21, they have opposite signs, so 21 minus 5 is going to be 16. So this is going to simplify down to being 16 over 12. Okay. At this point, you can either go to a mixed number or an improper fraction, whichever one you want to do first is perfectly okay. What I'm going to do here is I'll divide by their GCF. So 4 is their GCF, so go ahead and divide those both by 4. If we do that, this simplifies or reduces down to 4 over 3. Okay, and if you want to turn it into a mixed number now, you can. This is going to be 1 and 1/3. So either of these would be good answers here. I'm just going to write the mixed number version here, because if you got the mixed number, I'm assuming you knew the improper fraction as well. For D here, we have a subtraction problem, but we do have common denominators, which is nice. I'm going to go ahead and keep change and flip to turn this into an addition problem. And I'm also going to move around the negatives to the numerator, so it's a little bit less confusing. So I'm going to move the negative to the top, so it's going to be negative 13 over 6, okay? And then we're going to change the subtraction to addition, so we're going to add the opposite here of this negative 14 over 6. So the opposite of negative 14 over 6 is positive 14 over 6, okay, just like this. And then it looks like we probably don't have to do too much more after this, right? So we only had to move one negative just because we ended up flipping the second fraction or writing the opposite of it, okay? In the numerators here, we can go ahead and combine these. This is negative 13 plus 14. Right, they have the same denominator of 6, so we can add them together. And negative 13 plus 14, they're opposite signs, so 14 minus 13 is 1. So we're going to get here a difference of 1/6. All right, so for 4e, looks like we have a couple things we need to do. Number one, we're subtracting fractions, so we need common denominators. And number two, dealing with integers, subtraction is a little bit tricky, so sometimes it just makes more sense to turn it into an addition problem, which is something that we've been practicing here. So we can maybe start with that. We can keep change and flip and just turn this into an addition problem, okay? So rewriting this difference as a sum, we would have negative 5/8. That's our first fraction, and we're going to add the opposite of 3/10. The opposite of 3/10 is going to be negative 3/10. Okay, so we're really adding two negatives here, so we're going to add their absolute values later. Okay, what we're going to do next actually is to try to be super clear and just move these negatives to the top. So this is really negative 5 on top of 8, and then we're going to add here, I guess I can just rewrite it like this, where we have this negative 3 over 10. Okay, so at this point, it's maybe hopefully a little more clear where the negatives are. And let's see if we can find out where the least common denominator is here, or the LCD. Okay, so we have 8 and 10. And we're trying to figure out when 8 and 10 meet for that first special time. Let's see, that's going to be a 2, and then a 4, and then a 5. So what we can do here is we can multiply these numbers on the outside if we want. That's one way. Looks like 40, the LCD here, LCD is equal to 40. Okay, so how do we get to 40? Well, 8 can multiply by 5, so whatever we do on bottom, we do on top. And 10 should multiply by 4, so that's what the numerator is going to do as well. Okay, so this new fraction on top is going to be, let's see, negative 5 times 5 is going to be negative 25 over 40. And then for negative 3 times 4, that's going to be negative 12. So let's put negative 12 on top of 40. Okay, so at this point now we have common denominators, so we can rewrite this as negative 25 plus a negative 12. And that's all going to be dividing by 40. Okay, a negative plus a negative is just more negative, so we know negative 25 plus negative 12 should be negative 37. So we could rewrite this as negative 37 over 40. And then when we write our final answer, let's just move that negative back in the middle of the fraction bar, so we can write negative 37 over 40. All right, now that we have practiced adding and subtracting some rational numbers, let's go ahead in number 5 and check out multiplying and dividing. So we have this product and quotient. We're going to go ahead and multiply and divide rational numbers now. All right, so number 5, we have negative 3.2 times 8. So again, ignore the negative right now. We'll deal with that in a little bit. So let's take this 3.2 and just multiply it by 8. So let's see. 8 times 2, that's going to be 16, carry the 1. 8 times 3 is 24, plus 1 is 25, and then we need one decimal place. So we're going to go ahead and say this is going to be negative 25.6. Again, we had one opposite, so we have the opposite of 25.6, or negative 25.6. All right, so setting this up here, let's go ahead and write 1 for 8. And let's multiply this by 25 or 0.25. I'm going to ignore the negatives for just a moment and put them back in just a little bit. So 8 times 5 is 40, carry the 4. 5 times 4 is 20, plus 4 is 24, carry the 2. 5 times 1 is 5, plus 2 is 7. Okay, and then 2 times 8 is going to be 16, carry the 1. 2 times 4 is 8, plus 1 is 9, and then 2 times 1 is 2. And then if I go ahead and add these two rows together, we have a 0. 6 plus 4 is 10, carry the 1. That's going to be 17, carry the 1. That's going to be 3700. Keep in mind we had one decimal here earlier and two decimal places here, so we should have 3 decimal places in our product. And so we can go ahead and get rid of this 0 and 0. They're not necessary. So for our final product here, we're going to say it's positive 3.7. It's going to stay positive because we have 2 of those opposite signs. And the opposite of a positive is still going to be positive. For 5C, we are now multiplying fractions here, okay? Kind of up to you how you want to think about this, but if we are multiplying, again, ignore the negatives for now. We have one negative, so that means our answer is going to be negative, so try not to overthink that part. If we want to break this down maybe into some prime factorizations, that might be a super clear way of doing this. So for 15, we can say that's 3 times 5. And then for 12, that breaks down its prime factorization into 2 times 2 times 3. 16 in the denominator breaks into 2 times 2 times 2 times 2. And 25 breaks into 5 times 5. Again, if you need to pause and maybe write out the prime factorization trees, go ahead and do so. Once we have these prime numbers written out, these prime factors, we can actually cancel out any one we see on top and on bottom, because 5 over 5 is just equal to 1. 2 over 2 is just equal to 1, and another 2 over 2 is equal to 1. I think that's it though here. So on top we just have 3 times 3, and that's going to be 9. And then on the bottom here we have 2 times 2 times 5, and that's going to be equal to 20. So 9 and 20 are relatively prime. And so our final product here is going to be negative 9 over 20. Remember, we had one negative in the problem, so we should have a negative answer as our product. For D here, we have a division problem. So keep in mind, if you had maybe forgotten to keep, change, and flip our division problem into multiplication problem. So if we do that, we can rewrite this as 14 over 9. And then we're going to go ahead and multiply that by the reciprocal here, reciprocal or reciprocal. We're going to flip it upside down. So we're not flipping the sign here, right? So just be super careful about that. So I'm just going to go ahead and keep this in parentheses. We're flipping this upside down. So we're putting the 15 on top and then the 42 on bottom, okay? And so this is the keep, change, flip we're talking about. We're not flipping the sign. That is when we are turning subtraction problems into addition problems or addition problems into subtraction problems. Okay, our answer is going to be negative since we have one negative, so let's try not to stress too much about the signs right now. Let's just go ahead and multiply the fractions. And so let's go ahead and maybe write their prime factorizations out and break this down a little bit. So 14 is equivalent to 2 times 7, and this 15 on top can break down to 3 times 5. In the denominator, we have a 9, which can be 3 times 3. And then the 42 on bottom breaks down into 6 times 7, but 6 can break into 2 times 3. And then so we have the 7 over here. Looks like the 7 over 7 can cancel out to make 1. A 2 and a 2 can cancel out to make 1. And this 3 and 3 can cancel out to make 1. So in the numerator, we just have a 5. And then in the denominator, 3 times 3, that's 9. So our final quotient here, or the answer to a division problem, is going to be negative 5/9. Remember, at the very end, think about your signs. We have one negative, so we should have the opposite of 5/9 or negative 5/9. All right, here's E. For E, we have negative 2 and 9/15 divided by negative 1 and 4/26. So we have a negative divided by negative, which is just going to be a positive. So let's try not to think too much about the signs right now. Let's think about it later, but just remember it's positive at the end, okay? Let's turn each of these into an improper fraction first. So 2 times 15 here is going to be 30. 30 plus 9 is going to be 39. So this equivalent is going to be 39 over 15. Again, I'm leaving off the negatives right now, and I will deal with those later. And then over here for the second fraction, 1 times 26 is 26. 26 plus 4 is going to be 30. So this is going to be 30 over 26. Okay, so again, negative divided by negative will be positive, so we're going to have a positive answer, so no worries about the negatives right now. This is a division problem, so remember that we can keep, change, and flip and turn division problems into multiplication problems and vice versa. So if we keep this 39 over 15, go ahead and just write it 39 over 15, and let's multiply by the reciprocal of 30 over 26, which is just 26 over 30. Okay, now going ahead and just multiplying these fractions, you might be able to cross cancel. Feel free to do so. I'm going to go ahead and write out their prime factorizations here. So 39 is really 3 times 13 here, it looks like, right? So that's going to be 3 times 13. And this 26 is going to break down into 2 times 13. In the denominator, we have 15 breaking down into 3 times 5. And then 30 can break down into 2 times 3 times 5. If you were hoping that the 39 and 26 were going to cross cancel where the 15 and 30 were, it was tempting, but you actually cannot, so don't fall into that trap even if you really want it to happen, just because they seem like they were maybe going to, but once you flipped it upside down, then you couldn't cross cancel, so please be careful, okay? We can cross cancel these 3's though, so that's a nice little consolation for us, and then these 2's can also be cross canceled as well. Okay, in the numerators, 13 times 13 is going to be 169. And in the denominator here, we have 5 times 3 times 5. That should equal 75. Okay, so as an improper fraction, this would be our answer. If you wanted to write this as a mixed number, 75 times 2 is 150 with 19 left over, so we can write 2 and 19 75ths here. So we can write our quotient here just like that and say this is going to be 2 and 19 over 75. And again, the quotient here is positive because we had a negative divided by a negative, which is positive. All right, here is number 6. All right, for number 6, we have some powers, so we're going to go ahead and evaluate, which just means solve, and powers means we're dealing with some exponents here. Okay, so it makes a difference if we see parentheses or not. For 6a here, when we have this -4 in parentheses, that really means that we have -4 being multiplied by another -4. So a -4 times a -4, that will equal a positive 16. So we want to make sure we understand that. So a negative times a negative is a positive, so we can write this is equal to positive 16. Okay, as opposed to something like 6b, right? There's no parentheses, so really we have a negative here, but then it's a 4 being multiplied by a 4. Okay, again, we can use parentheses to show multiplication. So 4 times 4 would be 16, and there's one negative sign instead of 2 here. So this is negative 16, right? So slight difference here, but it's important because it changes your answers. Okay. For 6c, we have a -3 in parentheses, so try to think about what that means, but that means we have a -3 times a -3 times a -3. So 3 times 3 times 3, that's 27, but we have 3 negatives, so that's the opposite of the opposite of the opposite. So 3 negatives multiplied together gets you -27 as opposed to positive 27. If you think about something like 6d, though, we have this one negative in front, and then there's no parentheses around the -3, so it's really what's being raised to the third power. It's the 3 that's being raised to the third power. So in this case, it's a little different, right? We only have one negative instead of 3, but 1 and 3 negatives get you the same value either way. So 3 times 3 times 3 is 27. Because there's one negative, that's one opposite, that's still going to be -27. So it doesn't really make a difference for odd exponents, but it will make a difference for even exponents, and that's a nice pattern to kind of try to know over time. So obviously for something like 6e, we don't want to write this whole thing out, but if you can imagine for 6e that we have 50 negatives being multiplied together here, that's going to end up being positive, so it's just going to equal +1, as opposed to something like 6f, we have 50 positive ones being multiplied together, but there's a negative at the very end, so it's the opposite, so that would be -1. So hopefully that makes sense, but we wouldn't want to have to write all those out if we don't have to. Here's number 7. The 2 times we currently focus on using KCF, keep, change, flip, which is really just adding the opposite or multiplying by the reciprocal, are when we are rewriting division problems as multiplication problems, okay, as well as when we are rewriting subtraction problems as addition problems. Those are the 2 main times we do them. You can go the other way as well, just not usually as useful. Let's go ahead and explain a couple key similarities and differences between maybe these 2 scenarios. So we have some similarities and some differences, so just a couple key things here. All right, so maybe for a similarity, we can go ahead and think of maybe at least 1 or 2 things here. For similarities, we always leave the first, we're going to leave the first value alone, leave the first value the same, or leave it alone. That's the whole idea behind the keep, right? Another similarity we can maybe say is that we are going to make sure we are changing the operation, right? So whenever we go ahead and rewrite these problems, we are always changing like subtraction to addition or division to multiplication. And again, we can change multiplication to division and addition to subtraction, but a key similarity here is that we have to change the operation each time we do this. So maybe this would be sufficient enough that they have these similarities for both of these, for changing division to multiplication and changing subtraction to addition. We're going to always leave the first value the same and then change the operation. And then maybe for the differences, let's see what we can write here. Maybe we can say something like for the difference, right? For subtraction, what can we say that's specific about subtraction that's different about for division? So for subtraction, maybe we can say that the word flip, what do we mean by flip? That really means the opposite, right? So if we have a positive number, we're going to make it negative. If we have a negative, we're going to make it positive, okay? As opposed to when we're dealing with the division problems, let's think about what's different about division. So when we have the division problems, if we go ahead and flip, right? Keep, change, flip. What are we actually doing? Well, we're not writing the opposite. We're not changing the sign. What we're doing is we are finding the reciprocal of that second value. Reciprocal. Okay, so slight difference here, but the flip means something different when we are dividing and changing it to multiplication, as opposed to a subtraction problem turning into addition. 8a, true or false? The sum of a positive number and a negative number is never positive. This is false. If we have to try to maybe prove this here, we can maybe use an example here and say a positive number and a negative number is never positive. So if I said something like 8 plus negative 1, that's equal to positive 7. So that proves this statement to be false. So that's a counterexample. For 8b, you may cross-cancel when subtracting fractions. This is false. Okay, when you are cross-canceling, that is reserved for multiplication. So when you're thinking about cross-canceling, there's only one type of operation with fractions you can do that, and that is when you are multiplying. Okay, so even with division, make sure you keep, change, flip, and turn it into a multiplication problem before you cross-cancel. For 8c, you need common denominators when dividing fractions. This is going to be false. Okay, common denominators, let's think about when we need common denominators, but to get common denominators, or when do we need them, that is only specifically for adding and subtracting. Okay, so don't worry about getting common denominators when you are multiplying or dividing. Finally, for 8d here, the quotient of two negative numbers is always positive. This is going to be true. Okay, so when you divide a negative number by a negative number here, maybe something like this, we have negative 10 divided by maybe negative 2. Well, 10 divided by 2 is 5, and the opposite of 5 just stays as positive 5 here. So that's true. A negative divided by a negative, or the quotient, is always going to be positive. Let's check out number 9. For number 9, let's go ahead and find out or determine the specific location of each of these points, whether it is the quadrant or a part of an axis. Okay, so for 9a, we have point A, negative 5, comma 2. So that's from the origin. We move left and move up. This would be located in quadrant number 2, where everything is having a negative x value and a positive y value. So that's quadrant 2. For 9b, we have point B at 6, 8. So from the origin, we move to the right 6 and then up 8. That's going to bring us to quadrant number 1. Okay, that's where the positives are. So go ahead and write quadrant 1 here. For 9c, we have 0, negative 9. Whenever we see a 0, we know it's not in a quadrant. So we stay at the origin, don't go left, don't go right. So you can move 0 units horizontally, but then move 9 units down. If we're moving down, this would be located on the negative y-axis. Okay, so that's going to be on the lower part below the origin, but it's on the y-axis. For 9d, for we have point D, we have negative 6, negative 1, so it's from the origin 6 to the left and 1 down. That brings us to the quadrant with the negative. That's going to be over in quadrant 3. Okay, we have negative x and negative y values. For 9e, we have point E, which is 5, 0. So if you start at the origin, you move 5 units to the right, then 0 units up or 0 units down, so you stay right on the x-axis. But since we move to the right of the origin, this is going to be the positive x-axis, okay, since we're to the right of the origin. And then finally for f here, we have 7, negative 4. So from the origin, we're going to move to the right 7, then down 4. So if we move that way, we're going to end up in quadrant 4, because quadrant 4 is where we have always positive x values, but negative y values. That's quadrant 4. For number 10, the question is, do points that are horizontal from each other, okay, horizontal means left and right, have matching x coordinates or matching y coordinates, okay? So if we have them next to each other horizontally, so maybe we can make a quick sketch to draw 2 points and then make a comparison here. So if we have 2 dots that are next to each other, maybe like these two, what would match about them? They both move to the right, but then they move to the right different numbers, so they have different x values, but they move up the same amount, so they have the same y coordinates, okay? So we're going to say they have matching y coordinates. So their x's would be different, but their y's would be the same just because they're moving up the same amount here. For number 11, we have the question, do the points that are vertical to each other on the coordinate plane have matching x coordinates or matching y coordinates? Okay, so if you understood the one we just did, this hopefully can kind of piggyback off the one. And so we can see what if they are vertical to each other, so maybe 2 dots like this, right? And if you were going to plot them, they would move to the left the same number, but they would move up different amounts. So if they move to the left, right, then that means they have the same x coordinates, because x is talking about horizontal distance or left and right coordinates. But since one went higher than the other one, then their y coordinates would be different, leaving their x coordinates the same. For number 12, describe how we can find the distance, okay? Find the distance between 2 points that are in the same quadrant, okay? So if they're in the same quadrant, we just go ahead and subtract the absolute values of their non-matching coordinates. On the contrast, for number 13, if we're going to go ahead and find the distance between 2 points that are in different quadrants, we're going to do something slightly different. We are going to add the absolute values. Alrighty, here is number 14. For number 14, we're going to go ahead and use absolute values and write detailed work to find the distance between each of these ordered pairs here. Okay, so for A, we have point A, -5, comma, +2, and point B at -1, comma, +2. So let's see what we have here that we can work with. So it looks like we have matching y coordinates, right? These 2's do match. These are the y coordinates. So their non-matching ones are these two numbers of -5 and -1. Okay, so if they're both negative, that means that they are in the same quadrant. So remember, if they are in the same quadrant, we take the absolute values and we subtract them. So take whichever one is further from 0 first and put that in the first absolute value symbol and take away the one that is having a smaller one. So the absolute value of -5 is +5 and the absolute value of -1 is +1. So 5 minus 1 is going to be 4. So these 2 points of A and B would be 4 units apart from each other, right? That would be their distance. All right, so that's 14A. For 14B, let's see, we have point C at 7, -5, and point D 7, +8. So you can notice here they have matching x coordinates this time. So let's see, if we want to find out how far apart these 2 points are from each other, let's look at their non-matching coordinates. We have 1, -1, +, which means they are in different quadrants. If they're in different quadrants, let's add their absolute values. If we're adding, it doesn't matter which one comes first, just because it's commutative, meaning you get the same answer either way. So we're going to add the absolute value of -5 with the absolute value of +8. The absolute value of -5 is a +5, and the absolute value of 8 is 8. 8 plus 5 is going to be 13. So these are going to be 13 units apart from each other. For C, let's go ahead and see. We have 2 points, E at negative 4.2, comma 6.8, and F negative 4.2, comma 1.9. So it looks like we have matching x coordinates here of negative 4.2. So let's look at their non-matching coordinates of 6.8 and 1.9. They're both positive, so they must be in the same quadrant here. So we're going to subtract their absolute value. So take the one that has a greater absolute value first. So absolute value is 6.8. Let's take away the number with a smaller absolute value, which is 1.9. Now the absolute value of 6.8 is just 6.8, and the absolute value of 1.9 is 1.9. And so what is 6.8 minus 1.9? So let's go ahead and maybe do that subtraction on the side. And if we go ahead and do so, let's borrow, make that a 5, make this 8 and 18. 18 minus 9 is 9, 5 minus 1 is 4. So 6.8 minus 1.9 means that these 2 points are going to be 4.9 units apart. Checking out D here, we have point G at negative 5.5, comma positive 2.25, and point H at 6 3/4, comma 2 1/4. So let's see what's matching here. It looks like their Y values are both 2 1/4. So we gotta find out the difference or how far apart these X coordinates are from each other. Now they are opposites in the sense that one is negative, one is positive, so they're in different quadrants. If they're in different quadrants, we're gonna add their absolute values. So adding, it doesn't matter which one comes first. Let's do negative 5.5, the absolute value of that, plus the absolute value of this 6 3/4. Let's go ahead and add these two together. The absolute value of negative 5.5 is just positive 5.5. And then the absolute value of 6 3/4 is just going to be 6 3/4. Okay. When we're adding these two together, we can say 5 plus 6 is going to be 11 units. But then if we're taking a look maybe at the fraction parts here, so like looking at this 1/2 and looking at this 3/4 here, keep in mind that 1/2 is the same thing as 2/4. And then we have this 3/4. So 2/4 plus 3/4 is going to be 5/4. And then 5/4 is equivalent to 1 1/4. So if we add this back in, this is going to be 1 1/4 added on to that 11. So if we do that, we should get 12 1/4 units apart. All right, here's number 15. All right, for number 15, we have a problem. We're going to go ahead and find the area and the perimeter of a rectangle, okay? And we have these 4 different vertices or points or corners of the rectangle that we're given. We're also going to make sure that we provide a rough sketch, so a little picture, and then label things appropriately as well. So make sure we have our units included. All right, so I'm just going to make a rough sketch here and draw a rough x-axis and a y-axis. It doesn't need to be anything too crazy, but just to give us a better idea of what's going on here. So here's x and here's y. If we are plotting point A, which is negative 4, 2, that's going to be 4 units to the left and 2 units up. So maybe I'll call that point A. For point B, we have negative 4, negative 9, so 4 to the left, 9 down. So I'll call that point B, maybe something like that. For point C, that's going to be 7 to the right, but then it's going to be down 9. So it's going to be next to B, okay, roughly over there. And then point D is going to be 7 to the right, but then 2 up, right? So I'm going to call that D. That's going to be in quadrant 1. So connecting these, we should get a rectangle. So from A to B, these were vertical to each other. From B to C, these are horizontal to each other. From C to D, these were vertical to each other. And then from A to D, or D to A, these are horizontal. Okay, so there's a rough sketch of a rectangle. To find area and perimeter, we're going to want to find the length and the width of this rectangle, right? That's going to be necessary for both of those calculations. So the length, let's maybe call that AD, the length of side AD, and then for the width, let's call that AB. Okay, so it doesn't really matter what we end up doing that for, but let's go ahead and see if we can find out those dimensions. So for the length of AD, looks like for AD, we can look at these two values. We have A and then we have D. So let's see what is matching here. So it looks like they have the 2's. So this 2 matches this 2. So let's look at the -4 and 7. They're in different quadrants. So we're going to go ahead and add their absolute values. So 7 plus 4 is going to be 11. So that's going to be 11 units. Okay, I'll put 11U for 11 units here. And then let's see here. So if that's going to be AD, which is 11 units right here, then we know BC should also be 11 units. So I'm going to go ahead and label that as 11 units and 11 units, just so that's super clear. And then let's go ahead and see if we can find AB. Now, AB is from here to here, which is the same thing as DC, if you chose to use DC instead. So from A to B, looks like they have matching X coordinates of -4. But looking at their Y coordinates, we have -9 and +2. So it looks like they're going to be adding their absolute values. That's going to be 11 as well. So that's going to be 11 units. So we now know the length is 11 and the width is also 11. So this happens to actually be a square, right? So writing out this work here, we can say that for the area, right, area is equal to length times width. Now the length here is going to be 11 units, which we just found out. The width is also going to be 11 units. So 11 times 11, that's going to be 121, and that's units squared. Okay, so that's going to be one of our answers. I'm just going to put a box around this one. As for our perimeter, remember a perimeter is equal to twice the length plus twice the width. And so we have 2 of these 11 units on the top and bottom for the length. And then we have 2 of these other 11 units for the 2 sides for the widths. So 2 times 11, that would be 22 units across the bottom and the top, plus another 22 units going up and down the side. So 22 plus 22, we should have a total of 44 units going all the way around this rectangle for the perimeter. Here's 16. For number 16, let's just go ahead and see if we can find the area of a triangle given some vertices. We'll also, just like in the last one, provide a sketch so we can see what this looks like and make sure we label our units as well. Okay, so maybe let's just go ahead and start with a rough X and Y axis. Again, just providing a little picture here. Okay, so X and Y. Point A is at -5, -9, so that's going to be 5 to the left and 9 down, maybe somewhere like here. That's going to be my point A. Point B is going to be 6 to the right, and then it's going to be 9 units down, so that's going to be point B. And then that's going to be next to point A, right? They're horizontal to each other. They have matching Y coordinates. And then C is going to be +6, -1. So that looks like it's going to be somewhere there in quadrant 4 as well. So A and B are horizontal to each other, so left and right. C is stacked right on top of B, and then we have a triangle connecting, so AC would be the hypotenuse here. So this is a right triangle. Okay, so this is what we're looking at here. To find the area of a triangle, we really need to know 2 dimensions. We need to know the base, and we also need to know the height. Okay, so the base here, let's call that AB. That's probably the most common one to use here. So AB is going to be the base. The height here is going to be BC. That's going to be going up and down here. So call that BC. So let's go ahead and figure out these dimensions before we can actually find the area. So let's figure out the distance between A and B. So A and B looks like they have matching Y coordinates. So let's see how far apart is -5 from 6. Well, they're in opposite quadrants, or different quadrants. And then so add their absolute values. 5 plus 6 is 11. So a lot of 11s here. So we're going to get 11 units. That's going to be the base here. And then for BC, BC is this length, or that's going to be the height rather. And so between B and C here, what do they have? They have matching X coordinates. So how far apart are their Y coordinates? Well, they're in the same quadrant, so we subtract their absolute values. 9 minus 1 is going to be 8. So this is going to be 8 units, okay? So how do you find the area of a triangle? Well, for a triangle, remember, area is equal to 1/2 multiplied by the base multiplied by the height. So 1/2 multiplied by the base. Well, the base here we know is going to be 11 units. And then the height we found out is also 8 units. Okay, so we have this information. If we multiply 11 times 8, that means the area would be 88 square units. So 11 times 8 is 88. units times units is units squared. That's if this was just a rectangle. And so half of 88 is going to be 44. So the area of this triangle would be 44 units squared. Okay, don't forget to take half of your product there, or after you multiply. For 17, we are given 4 vertices, or the 4 corners of a trapezoid, and we are going to either use one of these two methods. So we have these points. We can either decompose, which means break it down. We can break down trapezoids into rectangles and triangles, which we do know how to find the areas of. Or you can use this fancy formula, which is to find the area of a trapezoid. You basically average the 2 parallel sides, or average the 2 bases, and then multiply that by the height. Okay, so we're going to go ahead and find the area of this trapezoid, and also make sure we make a rough sketch so we're picturing it correctly, and then label our units. Okay, so let's go ahead and just, make a quick XY plane. And so we can go ahead and see like what this shape looks like, and we can accurately get our dimensions of everything here, right? So let's see here. So our first point M is -5.5, -6, so that's in quadrant 3. So I'm going to call that point M here, okay? And then for, we have point A. So point A is 7, -6, so it's going to be 7 to the right, and then 6, -6 down. So I'll put that over here. That's going to be A. That looks like it's horizontal to it. Now for point T, we have 7, 3.5. So we have to go 7 to the right and then 3.5 units up. So maybe something like here. That's going to be T. And then H, we have, we're going over from the origin, looks like half a unit to the right and then 3.5 units up. So this would be H. Okay, so M-A-T-H, that spells math. And so here we have the horizontal ones. Here we have vertical points to each other. Here we have horizontal points to each other. And then from this distance from M to H, this is going to be diagonal. All right, in hopes of being thorough here, I'm going to use both methods. First, I'll use the formula though. So this one over here, this we'll call this B1, we'll call this B2, and we'll call this H. So the 2 bases are always parallel to each other. So if you want to find out how long HT is, right? So we have to figure out these dimensions. So we'll call this B1. Go ahead and label on the side here, B1, and then B2, the 2 bases, and then the height. B1 is going to be this HT. So we have to figure out how long HT is. B2, we have to figure out how long AM is. And then H, that's going to be the length of AT, or segment AT. Okay, so for HT, let's see, we have H, and then we have T. They have matching Y coordinates of 3.5. So we have to look at their non-matching values, which are 1/2 and 7. They're in the same quadrant, so we're going to subtract their absolute values here. So 7 minus 1/2 is going to be 6.5. Okay, so from H to T, or from T to H, that's going to be 6.5 units. Okay, so we can write 6.5 units. And then if we go ahead and look at AM, that's going to be this B2 over here. So A and M, these 2 points here, they have matching Y coordinates, right? And then so if we look at their X coordinates, they're in different quadrants. So add their absolute values. 5.5 plus 7 is 12.5. So we're going to get a total of 12.5 units here. That's going to be how far across. So again, this 6.5 units is up here, and this 12.5 units we just found out is down here. That's how long each of those are. Now for AT, that's going to be this vertical length over here. So let's figure out how far A and T are from each other. They have matching X coordinates. So if you look at their Y coordinates, we have 1 negative, 1 positive. So add their absolute values. 6 plus 3.5 is going to be 9.5. So that's going to be a total of 9.5 units. Okay, so now that we have all our measurements for using this formula to find the area of trapezoids, we can go ahead and plug it in. So I'll go ahead and do that first here. So the formula is area is equal to B1 plus B2. So B1 is 6.5 units plus B2, which is 12.5 units. That's B1 plus B2, that's over 2. and then multiply that by the height, which is 9.5 units. On top, 6.5 plus 12.5, that's going to be 19. So it's going to be 19 units over 2 multiplied by 9.5 units. So 9.5 units, that we can turn that into an improper fraction here, right? So that's going to be 9 times 2 is 18 plus 1. That's going to be 19 over 2, and that's units as well. Now, 19 units times 19 units should be 361 square units, and 2 times 2 on bottom is going to be 4. And so if we turn that into a mixed number, I think 4 goes into that 90 times, so that's going to be 90.25 square units. This would be the area of this trapezoid. Now, what if we went and decomposed this into 2 separate shapes? So what if we looked at this triangle separately, maybe a triangle that looks like this, right? And then we have a separate shape here on the left and the right. So we have a rectangle to the right here from H to T to A to this new point. I'm going to call this new point over here, I don't know, we'll call it S. Okay, so calling that point S makes this a little bit easier maybe to organize. And if we go ahead and find the area of the rectangle, well, we already know the length and the width. So for this rectangle, we already know HT and TA. So we can go ahead and multiply that. So let's go and say the area, and then I'll just draw a little rectangle here. So the area of the rectangle here is going to be HT, which is what, 6.5. Let's take 6.5 units, and we're going to multiply that by TA or AT, which is 9.5. So that's 9.5 units. We're multiplying, so here we have to change to improper fraction. So 6.5 is the same thing as 13 over 2 units. 9.5 we know is going to be 19 over 2 units. Now, 13 times 19 is 247, so that's going to be 247 over, and then 2 times 2 is 4, so it's 4 units squared. So I'm going to leave that alone for just a moment, but that would be the area of the rectangle. Now, let's take a look at the triangle. So for the triangle, this one's going to take a little bit more work for us, right? So for this triangle, what do we need to find out? We really need to know how the dimensions are in terms of the base and then the height here, right? So the height of HS should be the same as AT. So we already know that is going to be this 9.5 units. So whatever this was, this AT, this is also going to be 9.5. So we can just use that. But we do have to figure out how long this MS is from here to here, okay? So let's go ahead and see if we can figure some stuff out. So this point S, right? This point S has to be below H. So if it's below H, what's its X value? That's gonna be half. So it's gotta, let's rewrite S's, this is a new dot we made. So it's gonna be half comma. Again, it's gotta share the X coordinate of H. So we have the 1/2 because it's below it. And then notice how this S is on the same level as A and M. And A and M have matching Y coordinates of -6. So if S is on the same level as it, it should also have a Y coordinate of -6. Okay, so that's going to be the location of point S. And so if we want to find out the distance between S and M here, then we look at S and we look at M. What do they have in common? Well, they both have matching Y coordinates. Hopefully that makes sense. And then look at their X coordinates. Their X coordinates are in different quadrants. So if you add their absolute values, 5.5 plus 1/2 is equal to 6. So the distance there is going to be 6 units. Okay. So for the base here, we're going to have 6 units. That's going to be the base. And then let's multiply that by the height. The height here, we said for SH is the same as AT. AT was this 9.5 here. So let's go ahead and keep using that 9.5. So take that 9.5 and put that right here. And keep in mind that when we are doing triangles, it's base times height divided by 2, or timesing by half, whatever you prefer to do. On top here, let's see what we're going to get. So this is going to be 6 over 1 units multiplied by 9.5 is 19 over 2 units. And then this whole thing afterwards we'll divide by 2, but we'll worry about that in a moment. We can cross cancel here. This is going to be a 1 and this is a 3. And then so what do we have here? 3 times 19. Let's just swing up over here. 3 times 19 is going to be 57. So it's going to be 57 units. And then it's we're still dividing by 2 here at the bottom, right? So 57 over 2 units. And I think this is squared because it's units times units, okay? Now if we take a look at 2 things here, we have the rectangle and then we have the triangle. We have to add these together since they are the 2 pieces of the trapezoid. So let's get common denominators. Let's do times 2 times 2. If we do that, we're going to get 114 over 4 units squared, okay? And then so we can go ahead and take this 247 over 4 and then add that to 114 over 4. And so let's see, 247 over 4 plus 114 over 4. This should add up to 361. 361 over 4 units squared. But notice that this 361 over 4 matches this 361 over 4. So this must be correct. And we will end up getting here as a mixed number as well, this 90 1/4, if you do the long division, units squared, right? So no matter how you do it, the formula is definitely less work to do here, but conceptually, if you don't know the formula, you can always break it down, these right trapezoids, into a triangle and a rectangle. Here is 18. All right, for number 18, let's go ahead and sketch and find the locations of 4 different ordered pairs that are 5 1/4 units away from this given point of 3, -1. Okay, so let's just go ahead and make the sketch and see where point A is and then go from there. So here's our X and our Y axis. Let's see, 3, -1, that's 3 to the right and down 1 unit, maybe something like here, that's point A. And so we have to go 5 1/4 units away, and we can go in 4 different directions here, right? So if we were to move up 5 1/4 units, well, we were at -1, and so if we go up 5 1/4, that should bring us to a point up here. I'll just make this point and we'll call it B. And so if we went up 5 1/4, the X value shouldn't change, so that should stay the same as 3. But the Y coordinate should be 4 1/4, right? Because it took us 1/4 to get to the X axis, and then we needed to move 4 1/4 more units, okay? But what if we went down? If we went down 5 1/4 units, we'll call this point C, okay? Again, what's going to stay the same is the X coordinate, right? That we're not going left and right, so that stays the same. Now, if we were at -1, which is under the X axis, and we drop 5 1/4 more, that should bring us to -6 1/4 units, okay? So that's going to be up and down. Those are 2 points that we've just located. What if we move to the right? If we move to the right 5 1/4 units, let's see what's going to happen here. That means if we're moving to the right, then the X coordinates are going to change, but the Y coordinates are not here. We'll call this point D. Okay, so the Y coordinate is going to be -1 still, but if we're at 3 and we move 5 1/4 units to the right, this should now be at 8 1/4 units. So 8 1/4, -1. We're still beneath the X axis here. And then what if we went to the left 5 1/4 units? So let's put a dot over here, and so that's going to be point E. So for point E here, what is that going to look like? Well, the Y coordinate is still -1, but if we're at 3 and we drop 5 1/4, that should bring us into the negative. So it's -2 1/4. So I'm just going to put that here, -2 1/4, and we don't move up or down, so that's still going to be -1 here. So this would be the 4 different locations of the points that would be 5 1/4 units away from that point A. Here's 19. Consider the following very realistic scenario. So Mr. Lee is standing on the edge of a rock that has an elevation of 23 meters above sea level. Okay, Mr. Lee then slips and falls downward in the direction of 40 meters down. Okay. From here, Mr. Lee swims upwards. I know it's a surprise. Swims upwards 3 meters and then rests. Then he then swims up 3 meters and rests 4 more times. Can't swim too much at a time, and then runs out of energy. So the question is what does the scenario kind of look like first? So for part A, we're going to go ahead and draw a detailed picture and then label to the best of your ability here. All right, so not the best artist here, so let's maybe just draw maybe a cliff or a rock of some sort here, and maybe we have the surface of the water looking something like this. Mr. Lee can be standing somewhere up here to begin with, and we can call this sea level. This is going to be 0 meters. Okay, so this is kind of what we're imagining going on in the beginning here. And so if Mr. Lee's height here is 23 meters above sea level, that means the distance between Mr. Lee and where the water is got to be 23, right? So that's that distance right here. Okay, so we know that Mr. Lee is starting 23 meters above sea level, so we have that down. He's going to slip then and fall downward 40 meters. So 40 meters, so the question is, does he hit the water? I think so, right? So we're going to then end up somewhere down here. So what's that distance? Well, this distance here is going to be a total of 40, right? From where I started, or where Mr. Lee started, to where he ends. This is going to be a 40-meter drop, and that's going to be a negative 40 since we're dropping here. Okay, it looks like from there, Mr. Lee is going to then be at the bottom of this picture, right? Okay, so from here we know that Mr. Lee is going to swim upwards 3 meters, and then we're going to rest. So that's just going to be going up 3 meters here. Just going to go ahead and label that as 3 meters. And then after that, it says that he's going to do this 3 meters 4 more times before he runs out of energy, right? So that's 1, and then you're just going to go 1, 2, 3, 4, right? That's kind of the idea here. So repeating 4 more times after that. Okay, so this is kind of my detailed picture. You might have something different, but this is visually, hopefully, what we're trying to be imagining. Now let's go ahead and write a mathematical expression, also known as like a sentence or a math problem that we can solve to figure out the final location of Mr. Lee. And let's label all the parts of the expression according to the scenario. Okay, so let's start off with the 23. That's a positive 23 because that's where we're starting as above sea level. And then we are going to be subtracting 40 because we're going downwards. And then we're going to be then adding 3 because we're swimming upwards 1 time of 3 meters and we're resting. And then we're going to swim up 3 meters 4 times. So that's going to be adding 3 4 times here. Okay. Then we run out of energy. So the question is like, what does this equal? Right? And this should tell us where we are located at the end. Okay. So what does all of this mean? So this 23, this is going to just be the starting. Okay. What does this minus 40 mean? This minus 40 means this is the fall. Okay. What does this plus 3 means? I don't know how to write this. Maybe just write swim up and rest. Okay, just trying to label it without being too confusing here. And then this 3 times this 4. I guess this is swim up and rest, but you're doing this 4 times. I guess we'll just call this repeat. Hopefully that makes sense to you. So repeat 4 times, doing the same idea. So those are kind of the 4 parts of this scenario that we were just talking about. Okay, so for part C, let's take a look. It says solve your mathematical expression here. So if we're at 23 and then we drop 40, right? 23 minus 40, that's the same thing as 23 plus negative 40. They're opposite signs, so it's going to be negative. So this would be negative 17. So that's where I was at my deepest point. All right, so this would be the lowest point. And then let's see, from there we are at negative 17, but then we swim up 3 feet here. So if we're at negative 17 and we swim up 3 feet, that's going to bring us to negative 14 feet. Okay, then what's happening here? Well, we're swimming up 3 feet 4 times, or 3 meters 4 times. I don't know if I keep saying feet, but I should say meters. Sorry if I've been saying feet. So we're at this 3 times 4. 3 times 4, we can multiply 3 and 4 together to get 12. And then so what are we doing? Well, we were at negative 14, but we're swimming up a total of 12 feet here. So we're at negative 14 plus 12, and that's going to be negative 2. This negative 2 tells us our final location before I run out of energy. Final location here, we can say it's going to be 2 meters underwater. For question D, did Mr. Lee make it to the surface? Yes or no? We're going to go ahead and sadly say no, he did not make it. Alrighty, for part E, the question says, if yes, what part of your expression made the biggest impact on Mr. Lee making it? If no, which is what we came up with, what's one thing we could change? What's one thing that we could change in this scenario so that Mr. Lee does make it? Be specific, and then make sure we have some good reasoning and explanation. All right, so what's one thing that could have changed that maybe would have impacted Mr. Lee making it to the surface? Well, one, maybe if the starting height was higher, right? Starting location was higher, because when we fall 40, then you wouldn't go as deep in the water. Starting location was higher. That's one specific thing that we could change that would then maybe alter the result of whether he makes it or not. One thing could be falling less, falling a shorter distance. So if fell a shorter distance, then it wouldn't be as deep underwater. Okay, so that's another specific thing that we could change that could impact the survival here. Or one other thing I'm thinking of that could impact it would be just swim more, or swim further up each time before resting, right? So you know how there's that part where we were swimming upwards, only swam 3 feet at a time, right? And then rested, and then did it over here. Well, maybe we just swam 4 feet at a time, then we would have made it, all right? Or 3.5 even. That might have been enough to just make it to the surface. So these are 3 things. So there's a lot of things you could change to make this scenario where Mr. Lee does make it to the surface, but here are just 3 where maybe if the starting location above the water was higher, then we'd have a different outcome. If we didn't fall 40 meters, maybe just fell 20 meters or something like that, or maybe just fell 25 meters, something that you wouldn't go as deep underwater. And then also when we're swimming upwards to make it to the surface, maybe we just repeat it maybe one more time, or we could also say we could just swim a little further each time. So lots of different types of answers. Here is one final question. A map of a neighborhood is plotted on a coordinate plane. Okay, here are the locations of a few key places you plan on walking to with your friends in the order that they are listed in. So everything is in order from this top down here. Make sure we follow it. Assume that you and your friends walk directly to each location to the next, and you begin and arrive back at the public library. Okay, so what we're going to do here is we have the locations of each of these places. We have the public library, we have Chipotle, we have a park, we have Benny's house, we have Taqueria, and then a museum that we're going to check out and then go back to the public library here. So let's go ahead and make a sketch here to the best of our ability. All right, let's start with the public library, which is located at 7, -4.2. So let's count over 7 units, 1, 2, 3, 4, 5, 6, 7, and down 4.2, 1, 2, 3, 4, and then 0.2. So I'm gonna go ahead and put this dot right over here. I'm gonna call that point A. Then for Chipotle, let's go ahead and see. That's located at point B, which is -5.5, -4.2. So we're gonna go 5.5 to the left from the origin. 1, 2, 3, 4, 5.5. Then down 1, 2, 3, 4.2. So maybe something like here. Okay, that's going to be point B. Next we have the park. The park is at negative 5.5 comma 2.3. So we're going 5.5 to the left. We're going up 2.3 units. So that's going to be right around here. Following, we have Benny's house. Benny's house is going to be at point D, which is negative 8.1 comma 2.3. 8.1 and then up 2.3. So maybe something like here. We'll call this point D. Next, we have another place. We got Taqueria that's located at E, which is negative 8.1 comma 7.1. So that's going to be above Benny's house. So let's go 8.1 to the left and go up 7.1. 1, 2, 3, 4, 5, 6, 7.1. So that's going to be right around here. Go ahead and put a dot and call that point E. Finally, we have this museum, which is located at F, which is 7 comma 7.1. So let's go to the right 7 units and then up 7.1. So maybe right around here. This would be where point F would be. All right, so making a sketch here, we would start at A and go over to point B. So starting at the library, we head over to Chipotle. From Chipotle, we then venture over to the park. That's where we're going over here. Then from the park, we're gonna head over to Benny's house. That's gonna be a pretty close little walk here. And then we're gonna go up to Taqueria. We go up to Taqueria here. That's gonna be located right above Benny's house. Then from Taqueria, let's go to the museum, cutting all the way across here. And that's going to be at F for the museum. And then remember from the directions earlier that we are heading back to the library to where we started at the end. All right, let's see what else we have to do. We have to figure out how many units in total that you and your friends walked here. All right, so let's see what we got going on. So let's try to do maybe from A to B first here. So from A to B, we can go ahead and figure out what that is going to be. So let's see, we have matching y coordinates here. So if we go ahead and add their x coordinates, the absolute value 7 plus 5.5, that's going to be 12.5 units. So from here to here, let's say that's going to be 12.5 units. Okay. And then maybe we can also do BC right now. So from B to C, that's from here to here. So let's see, B to C, they have matching x coordinates. So if we go ahead and add their two y coordinates here, 4.2 and 2.3, that's 6.5. So let's call that 6.5 units here, 6.5. Now for DC, these are pretty close. They should have matching y coordinates, which they do. They have 2.3 and 2.3. Now they're in the same quadrant, so we have to subtract their absolute values here. So 8.1 minus 5.5 should be 2.6. So you can go ahead and write that out if you need to, but this should be 2.6 units. Next for ED, let's go ahead and see how far those are. They should have matching x coordinates, which they do because they're vertical to each other. So here are their matching x coordinates. For their y coordinates, they're in the same quadrant, so we should subtract 7.1 minus 2.3, and that should be 4.8 units. So I'm going to go ahead and write that's going to be 4.8 units over here. Feel free to write that out if you need to. Next, to find this entire length of EF, you can do it a couple different ways. You can do it the way we've been finding distance, or you can notice that EF is going to be the length of this DC plus the length of AB. So if you add those two horizontal pieces together, we would get 15.1, and so that's going to be 15.1 units all the way across. And if you wanted to use that other method we've been using, you can notice they have matching 7.1s, and then so if you add 8.1 plus 7, that's still 15.1. So that works as well. Okay. Now to figure out this length of FA, that's vertical, and so we could just add the length of ED plus BC because they're both vertical as well. So 4.8 plus 6.5 is going to be 11.3 units. So that would be 11.3 for that vertical part here. Okay, so these would be all the measurements going across. So So for how many units in total that you and your friends are walking here, let's start maybe from the library, and we are walking 12.5 units first, and then we're going to be adding what next to that. Let's go from this 12.5 to the 6.5, so let's add the 6.5 units. Okay. After adding 6.5, we can go ahead and add on this 2.6. We'll go ahead and add 2.6 units on top of that. So if you add 2.6, that'll be the next leg of this adventure, this trip. And then we have 4.8, so let's go ahead and add 4.8 units. So adding 4.8, and then we're going to add 15.1. So let's go ahead and write plus 15.1 units. And then it looks like we have one more part, which is going to be this 11.3. So 11.3 units. And if we add these all up, this should be a total of 52.8 units all the way for this entire trip. Alrighty, one final question here. If each of these units on the coordinate plane actually represents half a mile in real life, determine how many miles you and your friends walked in total here. Okay, so what we do here is take this 52.8, that's how many units we walked on the coordinate plane, but we have to go ahead and multiply this by 0.5 because each of them is worth half of a real mile. Okay, so if we multiply what it's worth by how many there are, that'll get us the total amount in real life here. So 8 times 5 is going to be 40, carry the 4. 5 times 2 is 10, plus 4 is 14, carry the 1. 5 times 5 is 25, plus 1 is 26. And we should have 2 decimal places here. So we're getting 26.40. We don't need the 0 at the end here. So this is going to be a total of 26.4 miles. A little more than a full marathon, so that is quite a bit of walking. Alrighty, so there you have a bunch of different practice problems dealing with coordinate planes on the second half of this kind of review here. And in the first half, we also dealt a lot with different operations with rational numbers, fractions, and decimals, as well as integers, and dealing with negatives as well. Now, hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing. And I will see you in the next one.